Hello, my name is Carlos Gonzalez, and I will be doing my individual assignment on OLED displays. OLED is essentially organic light emitting diode. It's a solid state device which is made out of organic molecules that create light when they are exposed to electricity. OLED is particularly important because OLED technology uses less power than LED and LCD. OLEDs are made up of several layers. A substrate is the base layer of the OLED, it supports it. And organic layers, which are basically layers that are made of molecules that contain carbon and hydrogen bonds, are sandwiched between a cathode and an anode layer. As electricity flows between the cathode and the anode layer, the organic layers light up. Here is a brief video that talks more in depth about the making of OLED and its technology. It's a great resource and it's entertaining. Now, the process of electrophosphorescence, which is how OLEDs create light, is as follows. A current flows from the cathode, which is the conductor, to an anode, which is the emitter. The electrons from the current find holes in the organic layer. Once the electron settles, it causes light emission in the form of a photon. The color of said light depends on the organic layer. The intensity of the light depends on the intensity of the current. There are several types of OLED technology. There is the PMOLED, AMOLED, transparent OLED, top emitting OLED, foldable OLED, and white OLED. However, the transparent, top emitting, foldable, and white OLEDs are all based in the same premise of PMOLED and AMOLED. The PMOLED, or passive matrix OLED, is made up of cathode and anode strips. Where these strips intersect at perpendicular points lie pixels. These intersections create the pixels, and what pixels light up are controlled by external circuitry. They are easy to make. However, the passive matrix OLED consumes more power than other OLED technology because of the power required to run the external circuitry. AMOLED, on the other hand, is made up of sheets of cathode, organic, and anode layers. And AMOLED stands for active matrix, organic light emitting diode. And within this active matrix is a TFT array. The TFT array's job is similar to the external circuitry mentioned in the PMOLED, but it is built right in. And this TFT array uses little power and helps the active matrix keep up a quick recharge rate. Transparent OLEDs are basically OLEDs that are virtually see-through. When they are activated, they permit the flow of light in both directions. They can be based in either AMOLED or PMOLED technology. One particular use that I find interesting for the transparent OLED is HUD, or heads-up display. This is similar to what you would find in video games where it displays health or your ammo counter or your items, among other things. But in the practical, real world sense, it could be used to say, put the speedometer in your vehicle closer to your eyes by way of projecting the image onto possibly a windshield. The top emitting OLED is based with a solid or reflective substrate. They're typically AMOLED technology and they're great for smart cards, which are often seen as the little tiny gold foil like squares that are on the back of credit cards and debit cards. Foldable OLEDs are OLEDs that lie on a very flexible substrates. Um, there's been some talk of using these very flexible substrates as portable technology or weaving OLED into clothing and putting in tracking devices for outdoor survival and excursions. White OLED is OLED that emits white light more efficiently than the much touted and pushed fluorescent lights. It uses less energy to produce a brighter light that could, in the long run, be more environmentally friendly. OLED matters because it is efficient. OLED uses very little power for the same ends that LED and LCD currently do. And because it is made up of organic materials, organic light emitting diodes would produce less waste and are more environmentally friendly in the long run. What's more than this is that organic light emitting diodes have brighter and clearer images than both LED and LCD, and with these brighter and clearer images, we gain extended viewing angles. You no longer have to sit right in front of the screen or within a certain range of the screen. With OLED, you can see the screen with the same clarity from about 170 degrees in front of the projected image. What's more than that is that OLED technology is thinner than most LCD and LED technologies. Thank you for listening to my How Stuff Works tutorial, I suppose one could call it. My name is once again Carlos Gonzalez, GONZA494 at msu.edu. Feel free to email me if there are any questions. Thank you.